everyone, so it's Mrs. Slauson and we are starting section 3.4 in our notes. So I'm going to kind of skip over, try not to go too fast on this. I am on page 46 in our notes. So this is going to be built off of the warm-up that we did with properties of exponents. Do you add the exponents, do you multiply the exponents, or do you subtract the exponents? So before we get into that, we're going to be, evaluating radicals, so putting numbers in the radicals, simplifying it up and seeing what we can get out of it. And then we're going to look at operations with radicals, and that ties more into the warm-up than this first part. So the first thing I want to start talking about is if by chance you did the extra credit from the other day, I talked about domain with these new functions, and the domain just means what are the x values you can plug into your function and get an answer out of it. Because since we're working with square roots, I can't just put any number into the square root, because you can't take the square root of a negative number. So our domain is going to start to be limited, and that's why when we graph something, that's why our shape on the square root doesn't have arrows on both ends. It has a dot on one end and then an arrow going the other way, because there's only so many x's you can put in to make that equation work. So what we're going to talk about is, and I'm totally making this next part up, is somebody decided, well, that's not good enough. You have to be able to take the square root of a negative number. So they decided, well, guess what? We're going to do that, and we're going to call them imaginary numbers, like your imaginary friend maybe that you had when you were a child. And that, again, that was totally made up. That's not the real reason why there are these things called imaginary numbers. So let's talk about imaginary numbers. They're actually pretty easy to work with. So what they decided is, I want to take the square root of -4, and right now, if I try to do that on my calculator, let's see, will this show up? Kind of. I got a pretty good glare going from my window. If I did try to take the square root, let's see if this one shows up a little better, of -4, I would get an error message. It would say non-real answers, because you can't do that. But now we're going to start to get answers. And what they're going to do is anytime you try to take the square root of a negative number, we're going to call it imaginary. And I feel like I've just said that like a million times. So what we're going to do is we're going to break our numbers down into factors, which we've done before, like in the quadratic formula with that square root. And when we get to the square root of -1, we're going to replace it with an I. So whenever you get the square root of -1, it's worth an I. And on that same note, if I didn't want that square root there, I could square this side, and that would cancel out that square root, so you just get -1. And since I squared this side, I would square this side, and I get this basically. So two big things to come out of this part right now is when you take the square root of -1, we're going to get an I. Later, we're going to talk about if you get I squared, you can actually replace it with the value of -1. So an imaginary number looks like this. It's some number with I. B is just any number that we're already used to, a real number, numbers that we can put on a piece of graph paper. And I is just going to be that square root of -1. So real quick, now we're actually going to start the notes after all that. I don't even know how much time I talked there. So normally, again, we would get an error message, but what we're going to do is we're going to break this down into the square root of 4 and the square root of -1. We're going to do factors. Again, we did this in the quadratic formula. And then I can take the square root of 4 and make it a 2, and I can take the square root of -1 and make it an I. So the square root of -4 no longer has an error message. It says 2I. So same thing, square root of -25. I'll break it down into the square root of 25 and the square root of -1. And when I'm done, this becomes 5 and this becomes an I. So the way we write it is we usually put the number, the coefficient first, and the variable, the I, second. So on this one, I'll break it down into the square root of 7 and the square root of -1. Now 7 isn't perfect, and none of its factors are. So again, this is a great time to use that factor program on your calculator. So this will stay the square root of 7, and this will become the I. But in this case, they usually like the square root, the check mark, written last. I don't care if you put it first or last, but if this were a multiple choice test, this is the way you would see it written. So this becomes the I, and this stays the way it is. So for 200, the -200, first I'll start out with this. And then if I run my factor program, I actually realize that even though 200 isn't perfect, it has factors that are perfect. So I'm going to break it down even more. And then this becomes 10. This will stay the way it is, and this becomes an I. So these three parts are our answer. And again, usually the 10 is written first, the I would follow the 10, and we would put that square root of 2 after it. And then this is 10 times I times the square root of 2. Just like this is 2 times I, 5 times I times the square root of 7. So let's talk about this next part. This part is huge on your Chapter 3 test. So you definitely want to follow along here. Evaluating functions. So in evaluating functions, we're going to take this function f of x, which is the square root of x minus 4, and we're going to put these numbers in here. Now, because it is a square root, when I put these numbers in here, I actually might end up taking the square root of a negative number, which technically shouldn't happen. But now what will happen is we're going to get these i's out of it. So let's just start with f of 9. And that just means I'm going to take 9 and put it into my function. And when I do that, I get the square root of 5. And there's nothing I can do with the square root of 5. There are no factors, so this is as good as it's going to get. So I'm going to write my answer like this. My function, when x is 9, I get the square root of 5. So this part's going to go pretty fast. So now I'm going to put 20 in there. So 20 is going to go right here. I'm going to simplify this. So 20 take away 4. Well, that's just 16. And this does have a nice number. It's 4. So when I'm done, my function, when x is 20, is worth 4. Let's go to the next one. Let's put 3 in there. So this time when I subtract, I get a negative number. So 3 is not fitting into my domain of x's. I really shouldn't be picking 3 because I end up with the square root of a negative number, and I don't want to do that. But we did put it in there, so what happens when you take the square root of negative 1, just remember the square root of negative 1 is always worth I. So my function, when x is 3, I get I. I get an imaginary number. And then the last one, put 1 in. So this time when I put 1 in, I get the square root of negative 3. So for that, I'll break it down into these two factors. This I can't do anything with. There aren't any parts of 3, factors of 3 that are perfect. So I'll just leave it like this. And this will become an I. And again, usually the square root is written last, like this. And so my function, when x is 1, gives me I times the square root of 3. So the next thing it wants us to do is classify these numbers as rational, irrational, or imaginary. Well, the first part is these two. This is imaginary because I get i's, and so is this. So as soon as you get an I, imaginary number, pretty easy. So let's review from Algebra 1 the difference between rational and irrational. So the way I like to talk about it is, you have rational people and irrational people. Rational people are easy to work with. Irrational people are not. So what you want to do is look at your number and realize and think, is that easy to work with, or is that a really difficult number to work with? So working backwards, my answer 4, that's an easy number to work with. A rational number is a number that's a decimal, that's a short decimal, a repeating decimal. It can be 4, it can be 3.1. So this is what we call a rational number. But this number, the square root of 5, so irrational numbers are actually numbers that, if you did look at them as a decimal, are really long, messy decimals. They are not easy to work with. So rather than look at its decimal value, which I'm typing into a calculator right now, it's easier to write it as the square root of 5. But as a decimal, my calculator says it's ending, but this number keeps going, and that's a very messy decimal. So that is what I would call an irrational number. Excuse me, and notice I'm totally abbreviating here. So let's take a look at the next set. So this time I'm working with a cube root. Cube roots, I have no problems. I can take the odd root of a negative number. I just can't take the square root of a negative number. So here, I already know that none of these answers are going to be imaginary. They're just going to be rational or irrational. And this is just us working on our cube roots. So let's take 13, put it in there first. So 2 times 13 plus 1, simplifying this, I should multiply first, that's 26. And then once you add, you get 27. And 27 does have a nice cube root. It is 3. And just a reminder, your cube root button is when you press math. So if you press math and you choose that fourth option, you could put it in there and you're going to see that's a nice number. This is considered rational. Let's put -1 in. So first I'll multiply, that's -2, excuse me. And then once I add 1 to that, I get the cubed root of -1, which is also a nice number. It is -1, so that's another rational number. So if you notice, I'm not writing my answers in the same format. I'm just trying to save us some time. So the next one I put 4 in. So again, I'll multiply, that becomes 8 plus 1, and then I'll take the cubed root of 9. Now 9 has a perfect square root, but not a perfect cubed root. And if you try to type this in, again, I'll press math, I'll choose that fourth option. This is, well, maybe, a really long decimal. And again, even though it's ending on the calculator, it's actually still going. So this is what we would call an irrational number. And our last one, let's just throw a decimal in there. So 2 times -4.5, and then you're going to add 1. So if I multiply those, I get -9, and then I add 1. That ends up with the cubed root of a -8. And again, that's okay to have. The cubed root of a -8 is a nice number. It's -2. And since that's a nice number, easy to work with, it's rational. All right, that is page 46. Let's go to page 47. Okay, in page 47. So the first thing is, this is a little bit of review from Algebra 1. So what we need to talk about is that we're now going to work with exponents that are fractions. So in our warm-up, we did exponents that were integers, and we either added them, subtracted them, or multiplied them, and then means the exponents. So what we're going to start to see now is, since we're in this chapter that has all these check marks, is that you can actually take these exponents that are going to be fractions and you can rewrite them as a radical. So I just want you to notice the format. So this little number here is called the index. That would be like the square root and the cube root, and that becomes the denominator of my exponents. That's a fraction. Okay? So for instance, just some things on the side. If you ever see a to the 1/2, well, that just means the square root of a. If you ever see a to the 1/3, that's just the cubed root of a. If you see a to the 1/5, then that's the fifth root of a. Pretty simple. But sometimes you're going to have some other numbers in there. So like a to the 2/3. So what you can do is you can rewrite it. And again, the denominator will become the index number, and then I'll just rewrite this as squared. Or a to the 4/5. Well, I'll just rewrite it. The denominator is the little index number, and then we usually wrap it in parentheses, and the numerator becomes the exponent. So just understanding that you can write these things two different ways, but they mean the same thing. Like a half is the same as 5/10, it's the same as 50%, it's the same as 0.5. All mean the same, they just look different. So what we're going to talk about now is we are going to be working with these radicals down here. Some are radicals, some are exponents that are fractions. And what we're going to do is, in this case, we're only going to look at multiplying and dividing, because that's much easier. And normally in a non-COVID year, we would look at this a little bit more. But the main thing is to realize that if you have a radical, you can multiply or divide them if they have the same index. So if they're both square roots, both cube roots, both fourth roots. And that if you have exponents, you can multiply or divide them if they have the same base. And to know that you can go back and forth from something with an exponent, a power, to a radical. That's what this was demonstrating. So this was an exponent, now it's a radical. This had an exponent, now it has a radical. So again, for COVID, we're going to leave this out, and we're just going to do this. So let's take a look at this. So we have this problem, f of x and g of x, and we are going to multiply them. So right now, when I try to multiply these, according to what I just said, multiplying, and these are radicals, they have to have the same index, but they don't. This is a cube root, and even though we don't see it, there's a little 2 there. So right now, I can't do this because they don't have the same index. But what I can do is rewrite it as an exponent, and then maybe I can work with them. So I'm going to take this idea of what I wrote up here, and this is going to be the square root of x is like the 1/2 power. And then there's the 3. And the cubed root of x, that's like a 1/3 power. And now when I look at this, these are powers. This is an exponent problem. And as long as they have the same base, which they do, they're both x's, I can do this. I can do what we did on a warm-up. So what I'm going to do first is just organize this. I'm going to put my numbers together, and I'm going to put my common bases together like this. And this, you did do this in Algebra 1. I think it was Chapter 2 when you guys were a freshman. So anyway, 3 times 15, no problem. That's 15. So just like our warm-up, when these bases are the same, I can add the exponents. The only problem you're going to run into is you have a fraction, so you have to remember your rules of fractions. So we will be adding the fractions, and the rule is you have to have a common denominator. And that common denominator is going to be 6. So I'm about to move these into a denominator of 6. So to turn this so it has a denominator of 6, I'll multiply the numerator and the denominator by 3, and I'll multiply this numerator and denominator by 2. So I get 1 6, so that when 2 6, so that when I add them, I get 5 6. And that is the exponent. It now becomes x to the 5/6 power. So when we're done, f of x times g of x, that becomes 15x to the 5/6 power. I'm going to skip the second part, okay? All right, let's take a look at it. And this time we're going to multiply, we're going to divide, and we're going to do a composite. So starting with this, we're going to multiply these two. So x to the 2/3 times x to the 5/2. So just like the warm-up, same base. I can multiply these if they have the same base. So I just have to add the exponents. Again, if you saw this as x to the 2nd times x to the 5th, you would add those exponents and you have x to the 7th. But because they're fractions, we're going to get a common denominator. So if you notice, we're going to stick to the same denominator in all these problems. It looks like it's going to be 6 again. So I'll multiply this one by 2. And I'll multiply this by 3, and I'll get 4 6 and 15 6, so that when I add them, I get 19 6. And that is the exponent to my problem, x to the 19 6 power. So now we're just going to divide them. So g of x will go on top, and f of x will go on the bottom. And again, remember when you divide, just like we did in the warm-up, if this was x to the 5th over x to the 7th, that would turn into x to the 3rd. But because they're fractions, it'll take a little bit more work. But the nice thing is, they're the same fractions. We're just going to subtract them. So 5/2 became 15 6. And then we're going to subtract 2/3, which became 4 6. So when we're done subtracting, we get 11 6. The question will be, where does that x to the 11 6 go, on top or on the bottom? So based on our warm-up, which is bigger? Do I have more x's on top or the bottom? Well, 5/2, that's 2.5, is more than 2/3, which is like 0.66. So all of my x's are going to end up in the numerator. And sorry, I don't even need a denominator. All right, the last one is we're going to do a composite function. So this says g is going to go into f. So I'm going to write f. And then instead of g of x, I'm going to write what g of x is worth, like this. And this says it's going to go all the way where that x is. So instead of x being to the 2/3 power, this is going to be to the 2/3 power. And just like the warm-up, if we had something like this, the rule would be you multiply the exponents. So that's what I'll do here. The nice thing about multiplying fractions is you do not need that common denominator. What you'll do is you can multiply across and then simplify, or you can simplify first and then multiply, which is what I like to do. So even though I can't simplify this fraction or this fraction, I can simplify the 2's going crisscross. Divide this by 2, divide this by 2, and then when I'm done, I get 5, because I've multiplied my numerators, and 3, I've multiplied my denominators. So we're done, and we get x. Oh, that's not a 5. I'm to the 5/3 power. I apologize. So just a little quick thing there. Okay. I think as far as the math goes and notes, we are going to stop there, and we're going to pick up together as a class now.